How ChatGPT and large language models work. Opening hook context and series recap. Welcome back to AI Fundamentals Explained. In our last episode, we broke down neural networks and how they learn patterns from data through layers of interconnected nodes. Today, we're taking that foundation and diving deep into the specific type of neural network that powers ChatGPT and every major language model you've heard of. You'll discover the 5 key technologies that make ChatGPT possible: tokenization, transformers, the attention mechanism, the training process, and prompt engineering. This isn't just theory. Understanding these concepts will make you dramatically better at using AI tools. Section 1. What makes language models special? Before we dive into the mechanics, let's understand what makes large language models different from other AI systems. Traditional neural networks are great at recognizing patterns in images or predicting simple outcomes. But language? That's exponentially more complex. Human language has context, nuance, grammar rules, cultural references, and meaning that can change based on a single word. When you ask ChatGPT, "What's the capital of France?" it needs to understand that capital refers to a city, not money, and that France is a country, not a person's name. Large language models solve this through sheer scale and sophisticated architecture. GPT-3 has 175 billion parameters. GPT-4 is estimated to have over 1 trillion. These aren't just bigger neural networks, they're fundamentally different in how they process information. Section 2. Tokenization. How AI reads text. The first step in understanding ChatGPT is tokenization, how it converts your text into something it can actually process. This might seem simple, but it's crucial to how the model works. When you type "the quick brown fox jumps," ChatGPT doesn't see 5 words. It sees tokens. Sometimes a token is a whole word like quick. Sometimes it's part of a word like jump and s as separate tokens. Sometimes it's punctuation or even spaces. Here's the key insight. Common words usually get their own token, while uncommon words get broken into pieces. The word ChatGPT might be split into chat, G, P, T because it wasn't common in the training data. This is why AI sometimes struggles with new terms or names. It's literally seeing them as fragments. This tokenization process also explains why ChatGPT has conversation limits. When it says it can handle 4,000 tokens, that's roughly 3,000 words, but it depends entirely on how your specific words get tokenized. Section 3. The transformer architecture. Now we get to the revolutionary part, the transformer architecture. This is the T in ChatGPT, and it changed everything about how AI processes language. Before transformers, AI processed language sequentially, word by word, left to right, like reading a book. This was slow, and the model would often forget what happened at the beginning of a long sentence by the time it reached the end. Transformers changed this completely. They process all words simultaneously, understanding how each word relates to every other word in the entire context window at once. It's like having the ability to see an entire paragraph as a single image, rather than reading it letter by letter. ChatGPT uses 96 transformer layers. Each layer refines the understanding further. The first few layers might identify basic grammar and word relationships. Middle layers understand context and meaning. The final layers generate coherent, contextually appropriate responses. Section 4. Attention mechanism. The secret sauce. The attention mechanism is arguably the most important breakthrough in modern AI. It's how ChatGPT knows which words in your prompt are most important for generating the right response. Think of attention like a spotlight system. When processing the sentence, "the cat sat on the mat because it was comfortable," the attention mechanism helps the model understand that it most likely refers to the mat, not the cat, based on the context of comfort and sitting. But here's where it gets fascinating. ChatGPT doesn't just have one attention mechanism. It has multiple attention heads running simultaneously. Some might focus on grammatical relationships, others on semantic meaning, others on emotional context. This multi-headed attention is what gives large language models their nuanced understanding. During each step of generating a response, these attention weights are constantly recalculating. The model is continuously asking, given what I've written so far, what words from the original prompt should I pay attention to next? Engagement bump section 5. The training process. Now let's talk about how ChatGPT actually learned to do all this. The training process happens in two main phases, and understanding this will change how you think about AI responses. Phase 1 is pre-training. OpenAI fed ChatGPT massive amounts of text, books, articles, websites, forums, essentially a large chunk of human knowledge up to its training cutoff. During this phase, the model learned to predict the next word in a sequence. But pre-trained models are actually pretty useless for conversation. They can complete text, but they don't follow instructions well. That's where Phase 2 comes in, fine-tuning with human feedback. OpenAI hired thousands of human trainers to rank different AI responses, teaching the model what humans consider helpful, harmless, and honest. This process, called reinforcement learning from human feedback, or RLHF, is what transformed a text completion engine into a conversational assistant. It's why ChatGPT tries to be helpful rather than just generating random coherent text. The entire training process took months and cost millions of dollars in computational resources. GPT-3's training alone required the equivalent of running a powerful computer continuously for 355 years. Section 6. Prompt engineering. Getting better results. Finally, let's talk about prompt engineering, how understanding ChatGPT's architecture can make you dramatically better at using it. This isn't just about being polite to the AI, it's about working with how the model actually processes information. Since ChatGPT uses attention mechanisms, being specific and detailed in your prompts gives it more relevant information to focus on. Instead of "write about dogs," try "write a 300-word informative article about golden retriever training techniques for first-time dog owners." Remember that tokenization and context windows we discussed? ChatGPT can only remember a limited amount of previous conversation. For complex tasks, provide all necessary context in your current message rather than assuming it remembers everything from earlier. Since the model was trained to follow instructions, you can assign it roles or ask for step-by-step reasoning. Act as a financial advisor and explain, or think through this step-by-step. Leverage the instruction following training. Conclusion.